Alright, here we have problem 1 from homework 11 that's asking us to derive J2, K2, J1, K1, and Z equations by implementing the state diagram with JK flip-flops. So step 1 here is going to be to create our state table where we have our current states A, B, C, and D, and then we're going to basically see what happens with each input of W, as well as what the Z output will be dependent on those inputs at that state. So first up, let's look at state A when W is equal to 0. Here we see on the chart that whenever W is equal to 0, A just goes back to itself. So this will be A. And then when W is equal to 1, we see that A goes to B. So this will be B. W equals 1, A goes to B. The case is the same here with B. Wherever W equals 0, it goes back to A. And then whenever W is equal to 1, it goes to C. Here we see at state C, same exact thing. W equals 0 goes back to A. And then W equals 1 goes to D. W equals 0 goes back to A. And then here, when W equals 1, it goes back to D. So that's our state table there. And then now we just have to look at our Z outputs. What is the Z output at each state? At A, it's going to be 0, B, it's going to be 0, C, it's going to be 0, and then D, it's going to be 1, as we see here. 0, 0, 0, and then 1 finally. Now we just need to transfer that to ones and zeros with our binary system. So basically, with binary, just imagine these as 1, 2, 3, 4, and as we know, to represent these integers, this is 1, or sorry, technically this would be 0, since binary starts at 0, so 0, 1, 2, 3. So then we have 0, 1, 2, 3 respectively for A, B, C, and D. So A is just going to be 0, 0 all across the board, and then B is going to be 0, 1, C will be 1, 0, D is going to be 1, 1. Our Z output stays the same because it's already in ones and zeros, so there's that. Now we're going to have to transfer all of this into this massive table here. So this is where it gets a little bit trickier, because there's some rules that are implemented here, where it says we are implementing it with JK flip-flops. So that's why we have J2, K2, J1, K1. And all of those, that basically is just saying, for J2, K2, we're looking at the Y values, and then J1, K1, we're looking at, J2, K2, we're looking at Y2, J1, K1, we're looking at Y1. That's basically all that's saying. But let's transfer all this. So lowercase y2, y1 will represent our present state. Our future state will be represented by capital Y2, Y1. So whenever W equals 0, we saw here that all that happens is this, they all go back to A, basically, or state A or state 0. When W equals 1, they progress forward. So A goes to B, B goes to C, C goes to D, and D circles back to itself. I'm going to pull up the rules here for the JK flip-flop real quick, so give me a minute. Alright, so here I have the rules for our JK flip-flops that basically says if a flip-flop that's at 0 goes to 0, then J will equal 0 and K will equal D. If a flip-flop goes to 0, or goes to 1 from 0, then J equals 1, K equals D. If it goes from 1 to 1, then J equals D, K equals 0, and it goes from 1 to 0, then J equals D, and K equals 1. So how we implement that into this is we basically just look at our present state for Y2 and Y1 individually. So here we say that the Y2 flip-flop 0 for when W equals 0, capital Y2 is also 0. So the rule we apply here is if a flip-flop 0 goes to 0, then we see that J is equal to 0 and K is equal to D. And because we're looking at our Y2 present state, and we're looking at our Y2 future state here, we are going to fill our J2 and K2 values with J equals 0 and K equals D, and what that basically looks like is this. I'll do another example here. Let's do an example for W equals 1. So we're going to look at our Y2 present state right here, and then our Y2 future state when W equals 1 right here. It does look like it's the same thing here, where it just goes from 0 to 0, so this is also going to be 0D. I'll do a different one here, where it goes from 0 to 1. A flip-flop going from 0 to 1, J will equal 1 and K will equal D. So 1D. And basically, we're going to fill out this entire table. I'm not really going to go through it one by one. Just apply the same rules over and over again, and I'll be right back. Alright, now we're at our final step here, where we just take our entire table and transfer it into a K-map to derive all of our equations, like the problem asked. I already did Z here because, as you can see, there's only one scenario where this output is equal to 1 for Z, and that's when Y2 and Y1 both equal 1. So we can just say Z is equal to Y2 and Y1. But for everything else, K-maps do get a little complicated, but again, just go row by row, column by column. It'll be pretty simple. I'll do the entire K-map for J2 here. So this K-map is going to be looking at our present state, Y2, Y1, and then our W input of 0 or 1. And specifically, we're going to be focusing on the output, the output of J2, which means we literally only need to focus on this column right here. We don't worry about K2, we don't worry about J1, K1. We just need to look at our J2 output for W equals 0 and W equals 1. So let's see. For our present state, 0, 0, when W also equals 0, we see that J2 is equal to 0. For our present state 0, 1, for W equals 0, we see that our output is 0 again. For our present state 1, 1, when W equals 0, we see that our output is D, and then for 1, 0, it's also D. Now we just do the same exact thing for when W equals 1. So basically, we're just going to look at J2 column here, and we see that at 0, 0, it equals 0. This is 1, 0, it equals, 0, 1, it equals 1, 1, 1, it equals D, and then 1, 0, it equals D again. Now you just pair them up like usual. Remember, you don't pair up for don't cares. They can only be used to make groupings of 2s or 4s or whatever. So we see here the 1 and the D can go together, which means that J2 is going to equal Y1 or W. Alright, once you complete all that, this is what you should get, and this is basically your final answer, where we implemented this entire state diagram with JK flip-flops.